Hey folks, welcome to this episode on drawing covalent structures. In this episode, we are going to be looking at drawing CH2O. First step is to determine how many valence electrons each of these atoms are coming in with. So we have C, H, and O. We have one of these, we have two of these, and we have one of these, not zero. All right. Now, looking at what group it's in, carbon is in group 4, so it has 4 valence electrons. Hydrogen is in group 1, it has 1 valence electrons, but times 2. And then oxygen has 6 valence electrons, so times 1 is this. So we will have 12 electrons in this structure. Step number 2 is to figure out how many they would need if they had a full outer shell. Again, so we have one of these, two of these, and one of these. Carbon and oxygen both require 8 valence electrons to have a full outer shell, while hydrogen only needs 2, so we'll have 4 there. So we will have 20 electrons in this particular case. To figure out how many bonds we're going to be creating, we have to look at what we have versus what we need. So we'll take 20 minus 12, and we will have 8 divided by 2, which means that, again, they share in pairs. And so we will have 4 sticks. So right away, we can see that we would have a central atom, most likely carbon, and then we have 2 hydrogens and 1 oxygen, so 3 terminal atoms. That would require 3 sticks. Here we have 4, which means that we will have a multiple bond somewhere, a double bond somewhere. Let's see if we have any electrons left. And so we have 12 to begin with. We are sharing 8, which means we have 4 remaining, divided by 2, and we will have 2 lone pairs. Again, the atom that goes into the center is the one that's going to have the most unpaired electrons. Carbon being in group number 4 will have 4 unpaired electrons. Hydrogen, only 1, and oxygen will have 6 valence electrons with 2 that are unpaired. So carbon's going to go into the center. Now, we're going to treat this area around carbon as a 360-degree circle. We have 3 different atoms, 2 hydrogens and 1 oxygen. So 360 divided by 3 is going to give us 120 degrees of separation. That's what we're going to do. We're going to put them 120 degrees away from one another. Now, we're going to start off with one at the top, and the one at the top that we're going to put is oxygen, because oxygen is different from the other 2 hydrogens. So by convention, we usually put the different atom or the different bond at the top location, and that's what we're going to do. We're going to put oxygen at the top. The hydrogen and the hydrogen are going to go over here. Now, without looking at the sticks, we have to bond it to the central atom, and we do that using 3 sticks, but what we notice that we have 4. Hydrogen can only make 1 bond. It only has 1 unpaired electron, while oxygen can make 2 bonds. And so we're going to put that extra stick with that oxygen to create a double bond. So we've been able to use all of our 4 sticks. Now, where do we place our lone pairs? We have to see what is currently okay and what currently has a full outer shell. Hydrogen only needs 2, and each of these hydrogen atoms have those 2 electrons by sharing those electrons in those covalent bonds. So both the hydrogens are good. If we look at the carbon, carbon is sharing 2, 4, 6, and 8. So it actually also has a full outer shell at the moment. So it doesn't need any lone pairs. Oxygen, on the other hand, only has 2 and 4 from those bonds. So it needs another 4 electrons, and we can give it those 4 by putting 2 pairs of electrons. So now everything has a full outer shell. Everything is good, and this is going to be the structure of CH2O. Hopefully you found that helpful. Thanks for tuning in, and tune in again for more examples of structures going forward.